Section 4.2, triangle congruence by side, 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 and side, angle, side. You can prove that two triangles are congruent without having to show all of the corresponding parts are congruent. So basically, we're going to save some time. And one of the ways to prove that two triangles are congruent is to merely show that the three sides of one triangle are congruent to the three sides of another triangle. Then the two triangles must be congruent. So if you can prove that all three pairs of corresponding sides are congruent, you can prove the two triangles are congruent themselves. So here we have the proof, and they've told us that LM is congruent to NP, and LP is congruent to NM. They've asked us to prove that triangle LMN is congruent to NPL. So the first step of this proof, we're going to go ahead and restate the given. So LM congruent to NP. And we know this because of the given. All right, so we've got two pairs of sides, one and then two. We need the third pair or the third set of sides. Well, clearly, this one should be pretty easy to find because the two triangles share a common side. And because they share a common side, we can go ahead and say that LN is congruent to LN, and we know this because of the reflexive property. So LN is congruent to itself by the reflexive property. Now we have all three sets of sides for the triangle. Therefore, we can say that the two triangles are congruent by side, side, side triangle congruence. And that's it. The other way to prove triangles congruence is you can also show relationships between a pair of corresponding sides and an included angle. So what this means is if you are able to show that two sides and the included angle of one triangle are congruent to two sides and the included angle of another, then the two triangles must be congruent. And they call this side angle side congruence. So in this case, as long as you have two sides, so here we've got AB and DE are congruent, and AC and DF are congruent, and you're able to show that the angle between them, in this case angle A and angle D, is also congruent, you can use side angle side congruence to prove the triangle's congruent. So here it says, what other information, if any, do you need to prove the two triangles congruent by side angle side? Well, here we know the two sides, or we already know the two sides here. We've got BA is congruent to GH and BC is congruent to FG. So the only thing we're missing would be the angle. So that means in this case, we need to know that angle B is congruent to angle G if we're choosing to use side angle side. But let's say we didn't want to use side angle side. What else could we do? Well, we could also then look and see about finding AC congruent to FH. So if we can prove that FH is congruent to AC, we could then use side, side, side congruence. So it depends on which one you want to use. Question 2, very similar. If you wanted to use side angle side, you might need to know that angle Z is congruent to angle T. So that's if you want to use side angle side. If you want to use side, 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 maybe you want to know that XY is congruent to RS. Right, so it depends on which one you're trying to use, side angle side or side, side, side. I know the direction said side angle side, but I'm choosing to go with one or the other. All right, now we've got a proof. They've given us that segment RX is congruent to segment SX and that segment QX is congruent to TX. They want us to prove that the two triangles QXR and TXS are congruent. First step, restate our given. And if we look carefully here, we're trying to prove using either side, side, side or side angle side. But there's no real way for us to show that RQ is congruent to TS. We don't have any rules for that. There's nothing we can use. But we should recognize that there is a relationship that happens between these two angles here, that we can prove that these angles here are congruent. And we should recognize that we have vertical angles in RXQ and SXT. So therefore we can state that RXQ is congruent to SXT by the vertical angle theorem. And by doing that, we now have side, angle, and side in terms of our corresponding angle pairs, or corresponding parts. Therefore, that's enough information to prove that triangle QXR is congruent to TXS by side angle side congruence. Would you use side, 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 or side angle side to prove these triangles congruent? Or is there not enough information to prove triangle congruence by side angle side or side, side, side? Well, looking at question 1, we've got two pairs of sides, but we have this common side amongst the two triangles. So we should have enough information here to prove side, side, side congruence, because we could use the reflexive property to prove that middle side congruent to itself. In the second example, we've got two pairs of sides, but we don't have much else. Or do we? Well, keep in mind we have these angles here, which we know to be vertical angles, and we can show vertical angles are congruent by VAT. Therefore, we should be able to prove congruence here through side angle side triangle congruence. All right, this time they tell us that BC is congruent to DA and that angle CBD is congruent to angle ADB. And they want us to prove that triangle BCD is congruent to triangle DAB. Well, right off the bat, they've given us an angle pair and a side pair. And we have to figure out where we go from here. Well, we know we start with the given. That's our first step. And then we draw our attention back to the diagram. Well, what else do we have? Well, the two triangles appear to share this common side. Well, anytime the two triangles are sharing a common side, we can use the reflexive property to show congruence here. So we should be able to recognize that BD is congruent to BD by the reflexive property. With that, we now have enough information to use side angle side to prove the two triangles congruent. In the next one, they tell us that segment BC is congruent to segment BF, and segment CD is congruent to segment FD. And they've asked us to prove that triangle BCD is congruent to triangle BFD. Well, once again, we look at the picture, we've got two sets of sides that are congruent, but we should also notice that there is a common side between the two triangles. Okay, and so as we go about the proof, we start with our given, but we're automatically drawn to the next step because we recognize the common side between the two. So that means we can automatically state that BD is congruent to itself by the reflexive property. Well, with that, we now have three sets of corresponding sides, which means the two triangles BCD and BFD are congruent by side, side, side triangle congruence. This time we're given that BD is the perpendicular bisector of AC. And keep in mind, perpendicular bisector means that the line BD is cutting AC at its midpoint, but is also creating right angles. So that's how we get AD is congruent to DC here. And we have the right angle symbol. So we've got a right angle here and a right angle here as well. And we were asked to prove that triangle BAD is congruent to BCD. So the first thing they do is they restate the given, and then they start telling us that AD is congruent to CD. Well, that's the definition of bisector. We know that BD cuts AC into two equal parts, AD and CD. They also tell us that ADB and CDB are right angles. Well, that's the definition of perpendicular. When a line meets another line and they're perpendicular, they form right angles. From there, we should recognize that angle ADB is congruent to angle CDB because they're both right angles. So that'd be definition of right angles or definition of congruence in this case. Since they're both right angles, they both equal 90 degrees. So they're congruent. The next step we should recognize, because right now we have side angle, is that we have a matching side or a shared side between the two triangles. So we should be able to state that BD is congruent to BD by the reflexive property. If that's the case, we now have enough information for side angle side congruence. So our last step would be to merely state that triangle BAD is congruent to triangle BCD by side angle side congruence. All right, here's an extra problem. They tell us that AB is parallel to CD. They also tell us that AB is congruent to CD and that X is the midpoint of AC. And so we're going to write this proof together. So first step, we'll go ahead and restate our given. So if we have AB is congruent to CD, we know that this is congruent to this. But we also know quite a bit of other information. If AB and CD are parallel, we have what is essentially, if you think about it, let's go ahead and highlight this. These are your parallel lines. If we make this our transversal, we have congruent angles here because they're alternate interior angles. And so we can use that. So angle A is congruent to angle C by alternate interior angles, which we can also abbreviate as AIA. In addition to that piece of information, we are also provided in our given statement that X is the midpoint of AC, which means that AX and XC should be equal, because that is the definition of midpoint. It's the point in the middle that creates two congruent segments. So AX is congruent to XC, definition of midpoint. So with that piece of information, I now have enough to show side, angle, side congruence amongst the two triangles. So my last step would be to state that triangle ABX is congruent to triangle CDX by side, angle, side congruence.